Hello everyone. Welcome to the LeerCode problem 1 named TwoSum. In this problem, we are given an integer array and an integer target, and we have to return the indices of the two numbers such that they add up to the target. I can return the answer in any order. Let's analyze the example. In the first example, the array has 4 elements, which is 2, 7, 11, and 15, and the target is 9. So here we can see that by adding 2 and 7, we can make 9. And by using zero base index, the index of 2 is 0 and the index of 7 is 1. So we have to return 0 and 1. So this is the explanation. In the second example, the target is 6 and the array contains 3 elements, which is 3, 2, and 4. And now we can make 6 by adding 2 and 4. So the index of 2 is 1 and the index of 4 is 2. So we have to return 1 and 2 as well. And in the third example, the array contains 2 elements, which is 3 and 3, and the target is 6. And we can make 6 by adding 3 with the 3. So we have to return 0 and 1, the index of both 3. Now let's understand the constraint. Here, the array length can be in between 2 to 10 to the power 4, and each of the number can be in between minus 10 to the power 9 to positive 10 to the power 9, and the target also can be in between minus 10 to the power 9 to positive 10 to the power 9, and there is only one valid answer exists. So there is a follow-up question: can you make up with an algorithm is less than order of n square time complexity? Of course we can, because the algorithm which runs less than order of n square time complexity is optimal, and here I will show you the optimal solution. There can be thousands of ways we can solve this problem, but here I will show you the optimal one. Now let's understand the solution by using the first example. In the first example, we are given a target which is 9, and we are given an array which is 2, 7, 11, and 14. This array contains 4 elements, and the index of the element 2 is 0, 7 is 1, 11 is 2, and the index of 15 is 3. Now we have to determine whether we can make 9 by adding any of the 2 elements presented in the array. Here the algorithm is, we have to loop through the element, and for each array element AI, we have to determine whether there is an element in the map presented which the value is target minus AI. Now let's analyze this example by using this map. At first, we are presented in loop 2. So we will insert 2 here. As we all know that map contains the value in the key value pair order. So here the key is 2 and the value is the index number. And now we have to check whether target minus AI is presented in the set or not, which is 9 minus 2. That means 7. 7 is not presented here. So we have to do nothing, and we will insert the value 0 here. Here 2 is the key and 0 is the value, and 0 is the index number. Now we are in the element 7, and at first we have to check whether 9 minus 7 is presented in the map or not. 9 minus 7 is 2 and 2 is presented in the map. So we have to return the index of 9 minus 7, that means 2, which is 0, and the index of 7, which is 1. So in the first example, the answer will be 0 and 1. Now, I hope you understand the algorithm. Now let's move on to the code. At first, we are given a function which is named TwoSum and which return a vector of integers. The function has 2 types of parameter. One is the vector A, another is the target B. Now we have to take a map which is name is MP and an integer which is vector to store the result. Now we have to loop through from 0 to array size, and in each iteration we have to check whether we can find target minus AI in our map or not. If we find target minus AI in our map, then we have to insert the value of I and the map value of target minus AI into the vector, which will be our answer. And if by chance this if condition is not evaluated, then we have to make this operation, which is MP of AI is equal to I. That means we have to insert a entry in the map in the key value pair, where the key is A of I and value is the index element. Finally, we have to return the vector. Now, let's understand the time and space complexity of this given code. Here, the time complexity is big O of n, where n is the number of elements in the input vector. The reason for this is that the code iterates through the vector once, and each iteration involves constant time operations such as map lookups and vector insertion. And space complexity of this program is also big O of n. This is because the code uses a map to store elements from the vector along with their indices. In the worst case, all elements of the vector might be stored in the map. So in short, we can say that the time complexity of this algorithm is big O of n, and space complexity of this algorithm is also big O of n. Thank you everyone for watching this video. We will get back soon with another LeerCode solution.